Hello everyone. In this video, we are going to discuss the numerical from your unit number 1, that is vector analysis. And this numerical is basically related with the coordinate system transformation. Okay, so if you have any queries, you can drop me a mail onto my this email ID, and I will try to get you as soon as possible. Okay, fine. So we will start with what is given to us and what is to be done within this numerical. So in this given numerical, we are given with vector d, which is expressed in terms of that x and y, having the components along x and y direction. So this given vector d is in terms of what? It is in the rectangular system. It is in the rectangular, or you can say that to be in the Cartesian coordinate system. And we have to convert this rectangular or Cartesian coordinate system into what? Into cylindrical components and variables. So, roughly speaking, we just have to convert whatever is given in terms of that rectangular system into cylindrical system. And from the basic theory, we have whatever that cylindrical components or cylindrical system. It have the components along rho phi and z direction, having the variables related with the rho phi and z. So simply we have to convert what? We have to convert this x, y and z's into rho phi and z. Okay, so for that purpose we need to have the conversion table. So very firstly we will revise that one conversion table. It is not necessary that you should write in your theory exam, but that is necessary to convert these x, y and z is into rho phi and z. So very firstly we will look onto that table, and you just take the screenshot of that table, you just keep it aside, and then we will begin with the numerical. So before that, I will write that table for you. So this is the necessary table that we will be using throughout this numerical. So by using this table, you can convert the Cartesian system into cylindrical and vice versa. You can, if you are given with the cylindrical one, so you can convert it back into the Cartesian system. So very firstly, what we have for the Cartesian system, we have the vectors, that is to be x, y and z. So we have the components along x, ay and az. And for the cylindrical system, what we have? Rho, phi and z. So components will be along a rho, a phi and a z. Okay. Now if you have to find out the dot product in between this ax and a rho, so what will be that value? So that component or that value will be equals to what? That is equals to cos phi. Similarly, for the dot product in between this ay and a rho, so that value will be equals to what? That will be sin phi. And from the basic property of the dot product in between the two vectors, if they are not same, so az dot a rho will be equals to what now? That will be 0. Now similarly, dot product in between that x and phi component will be equals to minus of sin phi. Again, I would like to tell you that my handwriting is not as good as yours, so you just have to adjust with that one. You just carefully listen what's going on around over here. Now, the dot product in between that ay and a phi component will be what? That will be cos of phi. And dot product in between that z and phi component will be equals to 0. Dot product in between that ax and az, from the property of dot product, we have that to be equals to 0. Dot product in between y and z, that will be again equals to 0, and dot product in between these two same vectors, that is az and az, equals to 1. So you just take the screenshot of this table that we will be using throughout over this numerical. And another value that I'm going to write it over here is that if we have the components, that is x. So if you are given with the cylindrical components, that is rho, cos phi, rho, phi and z. So in order to convert that back into your Cartesian system will be like this one. So if you have if you want to find out, sorry, if you want to find out that x component, so that x component is equals to what? That x is equals to rho cos phi. Y component is equals to what? Rho sin phi. And that z component, so that z component is as it is. So these are the two things that we will be using to solve this numerical. Very firstly, we are going to find out what is the dot product in between these two vectors, and then we are going to put the values for that x and y. Now, why I am saying x and y over here? So if you look out for this, your given vector d, there is z term is missing over there, or you can say there is no z term, or you can say there is zero a z component. These are the one and the same things. Since we are not given with the z component, so we don't have to bother about what will be the value for that z. This is just for your reference purpose. Okay, fine. Now we will begin with the numerical. You just take the screenshot of this table, or you can write it somewhere so that we can directly write the dot product in between these vectors. Okay, fine. Now your given vector D, it can be expressed in terms of cylindrical system, and it will have the components like d rho, arrow cap, that is component along the rho direction. Then it will have the component like this d phi a phi cap plus dz az component along z direction. So assign it some equation. I'm going to assign it as equation A, or you can say any equation number. Okay, fine. So the thing is that whatever is your vector D, if it is had to be expressed in terms of cylindrical system, so it should be along the rho, phi, and z direction. Now where? So what is that d rho and that d phi and this dz over here? What is this d rho, d phi, and dz? So d rho is nothing but what? D rho is said to be the projection of your vector D, given vector D, in which direction? Yes, that should be in the arrow direction. What is missing? I have missed something over there. Projection of vector D in. Over here it should be in arrow direction. Okay, so what it should be? So it will be your given vector D and the dot product along the arrow direction. Okay, fine. Have you got this? If not, again listen what I have said. We just repeat that one. So d rho is nothing but what? Projection of vector D in the arrow direction, and it will be equals to what? Your given vector D. So what is the given vector? This given vector D, and it should have the dot product with the arrow in order to get the value for that d rho. Okay, fine. Now we are going to rewrite that one. So very firstly, we are going to write what is your given vector D. So very firstly, I am going to keep the bracket as it is. Your very first bracket of that 1 upon x square plus y square, or you can say the inverse of that x square plus y square as it is. Then we are going to multiply the second bracket. So what's in the second bracket? So that we have that to be x ax cap plus y ay cap into, or you can say it will have the dot product with arrow cap. Okay, fine. Now we are going to make use of this table over there. So well, I hope you have that table for your reference purpose. Still I have kept it over here. So by the time we are going to use that one, so you just keep the very first bracket of that 1 upon x square plus y square as it is. so that things not get messy. The thing is that we have to put the values of that x and y, but we will put that values later on. Very firstly, we are going to find out that dot product. So what is that ax, sorry, x into ax, and it is okay. So for your simplification purpose, I am again going to rewrite that one, x into ax cap having the dot product with this arrow cap plus this y into ay cap having the dot product with this arrow. Okay, now we are going to find that values. See, if you are enough expert, you can skip this step, huh? For your reference purpose, I have put that one. Now keep the very first bracket as it is for now. So that is 1 upon x square plus y square as it is, and this x as it is. So what is the dot product in between that ax and arrow? You can refer this table. Dot product in between that ax over here. Dot product in between this ax and arrow is that is equals to cos of phi. So we are going to put that ax dot arrow, which is equals to cos of phi. Okay, we have the very first one. Then this keep y as it is, and now we have to find the dot product in between this ay and this arrow. So what is that dot product in between that ay and arrow? So dot product in between that ay and arrow is equals to sine of phi. Okay, now we are going to put the value of that ay dot arrow, that is equals to what? That is sine of phi. Okay, fine. Now we have the dot product. Now we are going to make use of the values of that x and y. We are going to put the values of that x and y. So what we have for that x? So we have the x is equals to rho cos phi, and we have the y is equals to rho sin phi within that bracket and within that second bracket. So put that values. So what value we have for that x square? So this one will be as it is, and we have the x is equals to rho cos phi. So square will be what now? So x square will be equals to what? That will be rho square cos square phi. Now what about that y? So y is equals to rho sin phi. So y will be what now? Rho square, y square will be equals to rho square sin square phi. This is your very first bracket. Okay, let me shift that one. So again, we are going to write the values for that one. Okay, now this is what we have. 1 upon x square plus y square. So x is equals to x square is equals to rho square cos square phi. This will be rho square sin square phi. Now we have again x is equals to what? We have x is equals to rho cos phi, and this rho cos phi of the x into this cos of phi of the dot product. We have the y is equals to what? Y is nothing but rho sin phi into that sin phi again. Okay, now we have this to be what? This, sorry. I went into the flow. Okay, fine. So 1 divided by this rho square cos square phi plus rho square sin square phi, that is as it is of your very first bracket. And what about the multiplication within that second bracket? So that will be what? That will be simply rho cos phi into cos phi will be row cos square phi plus this row sin square phi. So that will be row sin square phi. Okay. Now we just have to simplify that one. So that will be what now? This row you can take it common out of this bracket. So what is left within the bracket? Cos square phi plus sin square phi, and what is left within the denominator? So for the denominator you can take the row square common. What is left? So left will be cos square phi plus sin square phi. So from the basic trigonometry property we have sin square theta plus cos square theta is equals to 1, or you can say since this numerator and denominator are same, so it will get cancel out. It will get cancel out. So what is left? So we are left with this row divided by row square, or you can say this row it will get cancelled out with respect to this row. Okay, so what value we have for that d row? So d row is equals to 1 upon row. D row is equals to 1 upon row. So this is the very first element within our this vector component. See, although it seems to be lengthy, but based on weightage, it deserves this much marks. Okay, fine. So assign it some equation, and here in this case, I am going to say it to be the what? Equation number 1. Okay, so if you scroll it down, you will see that we have put the values, and this is what we have found out. We have found the very first element, that is d row, and that d row value is equals to what now? We have that d row is equals to 1 upon row. Now we will move on to the second component, that is d phi. So what that d phi? So d phi it should be same in a similar fashion. So d phi will be what now? Projection of vector d in the phi direction, and that will be equals to what? Given vector d into phi cap. So we will move on to the this d phi component. Now we have this, that given vector, your d phi component is what? Your given vector d having the dot product with the phi. Now we are going to write that given vector d as it is, that as we have written in the previous part. So that will be what now? 1 upon this x square plus y square into your this given vector, that is x ax cap plus y this ay cap, and now we will have the dot product with respect to your this phi component. Okay, so this is your phi. Now you can refer that table from your screenshot. Now directly I am going to put the values for that one. Okay, so very firstly we are going to put the very first bracket as it is. So keep that 1 upon x square plus y square as it is. Now this again I am going to write it for you. If you are enough confident that you are going to take this product directly, that ax dot phi, you can skip this step. No need to rewrite it again and again. Okay, so y this y ay cap into this phi. Okay, now from that table you just refer that table. So from that table what we have for the dot product in between that ax and phi. So very firstly we are going to keep this first bracket as it is. Now we are going to keep this x as it is for now. What is the dot product in between that ax and a phi. So that ax and a phi is equals to what? So that is equals to minus of sine phi, then this y as it is. What is the dot product in between that ay and a phi? So that is equals to cos of phi. Okay, now we are done with the dot product part. Now we are going to put what? We are going to put the value of that x and y. So what we have for that x? We have that x is equals to rho cos phi. So what will be the denominator over here? So x is what? Rho cos phi. So that will be what now? Rho square cos square phi plus y. Y is what? Rho square sin square phi. Rho square sin square phi. So this is your very first bracket, and within the second bracket we have that x. So x is what? We have that x is equals to rho cos phi. So put that rho cos phi and this rho cos phi. Okay, fine. Rho cos phi phi. Okay, you just adjust with my handwriting. Rho cos phi into this minus of sin phi. So that will be what now? Minus of rho cos phi sin phi. And this y is what? We have that to be rho sin phi, rho sin phi into cos phi. Okay, now simplify that one. So if you observe for the second bracket, what you will see? You will see that this rho sin phi cos pi, which is with the plus sign, and this is again rho sin phi and cos pi, but it is with the minus sign. So what will happen? This plus and minus, it will get cancelled out, leaving this whole term that is equals to 0. So what is your second bracket? It is coming out to be 0, and we know that anything multiplied by 0 is equals to what? So that value is equals to 0. So what is the 0 value that we have? We have the 0 for your d phi component over here. D phi component. We have started this for your d phi component, and we have that d phi component to be equals to what? So we have that d phi component to be equals to 0. So this is you can say your equation number 2, or any equation number that you have given. I am going to write it as equation number 2. So this is your d phi component. Now next is we have to find out the dz component. Now in similar fashion we can write dz, and that dz is nothing but what? Projection of vector d in the z direction, and that will be equals to what? Your given vector d into az. But if you see our numerical or what is given to us, so there is no z component, or as stated earlier, I said that is it is with the 0 az component. Since that there is no az component, so we are going to write, since there is no there is no az component, so what will happen? This all of your dz term that will be equals to 0. So since there is no az component, see it is necessary to write this explanation why we are going to take that dz component to be equals to 0. Since there is no az component in given d direction for your given vector d, hence we have this dz is equals to 0, and assign it with some equation. I am going to assign it with your equation number 3. So this is what we have, that dz is equals to 0. Okay, fine. Now if you go through the previous slide, if you have taken the screenshot, what we have for that d rho, d phi and dz. So all of that values we are going to combine that one, So if you are going to combine our very first equation, that is equation A, that I have given. So equation A, equation 1, that is for your d rho component, equation 2 is for your phi component, and this equation 3, that is for your dz component with respect to your equation A. So what you will find, I am rewriting your equation number A here so that you will come to know that d rho vector d in terms of cylindrical system is equals to what? D rho a rho cap plus d phi a phi cap plus dz az cap. So this is what we have, and if you are going to put that value, so you will find that given vector d in terms of cylindrical system is equals to what we have for the d rho. We have that d rho is equals to 1 upon rho a rho cap. What we have for that d phi? We have that to be 0. What we have for that dz az? So we have that to be again equals to 0. So what is the ultimate answer that we have? So given vector d in terms of that cylindrical system is nothing but your 1 upon rho component, 1 upon rho component in the arrow direction. So this is our final answer. Okay, sorry. So this is our final answer. Okay. So if you appreciate my efforts, you can hit the like button and you can share it among your friends. Okay, so thank you. Uh, Sorry, one more thing I would like to add up over here, that whatever is this as per the numerical. So this is in terms of cylindrical components. So what are that components? Component is this arrow and variables as per they have stated. So variables are what? This row over here. Okay, so this is your final answer. Okay, thank you.